So here we are looking at the criteria for the continuity of functions of two variables. So I want you to think back to single variable calculus, and there was 3 criteria that we needed for a function to be continuous at a point. It still holds true here. So we say that a function z equals f of xy is continuous at some point x naught, y naught, if the following 3 conditions are met. So the first one is the function must exist at that point. So our function f must exist or must be defined at the point x naught, y naught. So in other words, f of x naught, y naught must exist. Our second criteria is that the limit of f of xy must exist as we approach, or as xy approaches that fixed point x naught, y naught. So the limit must exist. So in other words, the limit of our function f of xy as the point xy approaches that fixed point x naught, y naught must exist. So it must be equal to some real number, we'll say L. And last but not least, the criteria that brings it all together, the limit of the function f must be equal to the function's value at that point. So the limit of our function f must be equal to the function's value at that point. So the limit of our function as xy approaches x naught, y naught of our function f of xy must be equal to the function's value at that point. So in other words, we are taking the limit from step 2. So this limit must be equal to f of x naught, y naught. And if this criteria is met, then the function of two variables is continuous at that point, just like single variable calculus.